So we've learned a couple of the terms related to machine learning, and we have data available. We've already taken a bit of a look at the Austin bike share data. So it's out there, but we want to talk a little bit about how we can use it now. And that's where data transformation and cleaning are going to come in. So we have the data that we need, might not be in a format that we want. A lot of times, database tables or CSV files or JSON files, all of these things are going to have the data we want and other data as well. Sometimes things that are just not that useful for solving our problem. If we have a bunch of denormalized data, if we have a bunch of data that's ready to be processed, that's awesome. Usually pretty fast, but the problem is that there might be more than we need. And this is where a lot of the data transformation, data cleaning, feature engineering effort is going to come in. Usually you have to extract data. You very frequently have to transform data. Sometimes you have to validate data. You have to parse CSV files or JSON files. Sometimes you have to aggregate or marry data sources together. You might have to transform objects into individual attributes. You might have to deal with SQL tools. You may have to deal with ETL, extract, transform, load tools. You might have programming languages involved. You may be taking a bunch of files together. You may be trying to join files together. You may be aggregating files. It's tough to say. A lot of the problem with these types of problems is that they tend to be pretty particular to the use case that you're running into. So there's not exactly like a prescribed approach to cleaning data. It becomes something that you kind of understand more and more as you do it. So structured data comes in many types. If you think about data types, like most programming languages have an integer or a long integer. They have Boolean values, or bit values. They have doubles or floats or some kind of floating point precision number. They have strings. Like these are common to programming languages, databases, everything out there. But your data may have other attributes to it that are not necessarily just the data type. Like it might be categorical data. If you pick something from a list, that may be categorical data where, maybe we have, like the state you live in could be potentially categorical data. It's something you pick from one list. There's no, you can't necessarily order those in a numeric fashion. You can put them in alphabetical order, but like order is maybe not something that makes a lot of sense in that situation. You may also have ordinal data, which is something, like a scale where you might, but maybe it's not a perfect scale. So like you might ask somebody, how are you feeling today on a scale of 1 to 10? Well, is everybody who marks 10 going to feel as good as everybody else who marks 10? Or is somebody who marks an 8 feel twice as good as someone who marks a 4? Like, it's hard to answer these questions. So that we tend to think of as ordinal data. There's definitely an order to it, but the order is not universal, or not potentially universal, or it may not be like in order of degrees. So like you can't necessarily say that there's a numerical relationship between a 7 and an 8, but you can say that an 8 is a different thing than a 7 in one direction. Likert scale questions where you might have like, how much do you agree with this question, from strongly disagree to strongly agree. Somebody who marks on one side of that scale has a difference from somebody who marks on a different point on that scale, but it doesn't necessarily mean much beyond that. These ratings, these numbers sort of have that, this is more than this or this is less than this relationship. It can also be numeric or continuous data. You might have data that just goes from 0 to 100 with every possible, point in between. It could be 0, 1, 2, 3, 4, 5, 6, or 7.31456 It's hard to say where you break that data up. So continuous numeric data can be a different kind of thing altogether. You might also have freeform data, like data that just doesn't necessarily conform to a particular rule, or maybe it's just wide open. And this is why we need to think about feature engineering, because data is very messy. Data may require cleaning. And when we talk about cleaning data, again, there's not like a precise definition here, but it's usually making our data usable. So, there may be missing values in your data. That's an interesting problem that comes up frequently. What do you do when you have missing values? Do you just throw that data away, or can you still use it? Is the missing value important? Maybe we don't even care about that value for training our model. There may be entirely missing sections. You may have an entire category of data where just nothing is filled in. These are common problems that you kind of have to think about case by case how you're going to handle them. You may need some rules or heuristics to make that effective or usable. You might be able to say, well, if columns A, B, and C are filled in, maybe we can assume that D was not relevant, or maybe you can assume that we can impute data. Imputation is an interesting approach, because maybe you can just take an average and put that in for every single one of these missing values. Maybe you have to have some rules or heuristics about how you calculate what value is there. Maybe you throw that data away entirely. All of these are questions that you have to ask, and sometimes you have to change your mind on. Sometimes you train a model in a particular way and find that maybe that imputing data in one way is actually causing some problems. Maybe it's causing incorrect types of predictions, or maybe it's causing all of your predictions to go in a particular direction. If you have a lot of missing data for a column and you just make that an average, if you say all the missing data is just an average, well, that average may then overwhelm the data that you're using, and it may cause your model to want to predict whatever the average is, which might not be a bad outcome, but it might be a very bad outcome. So I think this is another thing that you have to think about when you're looking at data, is how does all of this data that I'm using, how does it affect what the results are going to be, and how does missing data affect what those results are going to be? You might have to enhance your data. Like a thing that would be really useful in the bike data, if we're going to take a look at predicting trip duration between two stations. A thing that would be very useful would be trying to understand what the traffic conditions were. If we had that kind of data, we could make a much better model. If we had data on who went from point A to B, or who stopped for lunch on the way, like that would be enhancing data. We could really make our data much more effective if we had those things available. But you might not have those types of data available. You might have to remove data. It may be that certain kinds of data are just skewing your model, or it may be that your model doesn't work well in certain conditions. Maybe you just don't run predictions in those cases. You might have to normalize some values. So like a really good example of this is maybe you have some continuous data where there's a distribution of that data. So like maybe there's a distribution where there are a few outliers very far on the ends of your data that could really make things, make your calculations, make your predictions a little skewed in a particular way. Maybe you have a few, maybe the average of your data comes out to be a 60, and almost all the values are between a 50 and a 70. But then you have one or two values that are like in the millions, and that affects your entire your statistics and your distribution. You may be taking a broad distribution and condensing that. Like that's when your model is predicting. Sometimes it doesn't care about the outright raw data. Sometimes that part doesn't matter that much. Your model is built to make a prediction, so it really depends on the inputs that it's trained upon and the inputs that it is going to use when it makes a prediction. So maybe taking this value, maybe it's a percentage. Maybe you need to scale that down to a 1, 2, or 3 categorical value. Maybe we have a range of percentages between 0 and 50 that is a 0, and then percentages between 50 and 80 that we have to condense to a 1, and then so this type of transforming, or maybe simplifying data, or maybe normalizing your data, or maybe modifying your data, all of these may be approaches that we need to take when we are actually building a model and engineering our features so that we can train that model effectively. And again, there's no hard and fast rule for these things, but as you start doing, you start to kind of understand that this is actually causing a problem, or this is not providing the right kind of insight. So I need to adjust how I'm using this data so that it can be used more effectively in my model. The other question is validity of data. When you move around formats, one thing that you might find in a relational database management system is that it can enforce relationships. But when you come out of a relational database management system, maybe those relationships no longer exist. Maybe they're not well enforced anymore. Maybe that is going to cause you some problems. So, these special rules pertaining to the structure, the format, the validity of your data, you lose them when you come out of the database. And, to be very honest, it's very likely that working with a database is not the best way to train your model. It could be that, just dumping your data into a CSV file can be read, parsed, and used in your model much more quickly than retrieving database records. Or it could be that you have to export this to, some other type of format that is just easier for your model to work with. So this validity may be lost, or this validity may be changed. I think The first sort of predictive analytics project that I ever worked on, the data that we started with was actually, it was in about a dozen, maybe 15 different CSV files. And some of those CSV files were very relevant and some of them were not, but some of them were, some of them had very little information in them. And the biggest part of that project was not actually trying to figure out which model to use or how to train it or how to build that model. The biggest part of that project was figuring out how to take all of that disparate data and all of that related data and actually build a single CSV file so that it could be very easily read and parsed by the tools that we're using to import data into the model. So this is kind of a big part of the problem when we get into machine learning, is how do we manage our data? How do we analyze our data? How do we understand our data? And how do we take that raw data and do something to it so that our model can use it most effectively? So we're going to explore that a little bit. We'll probably build a kind of bad model because we don't have as much data as we'd like to have, but we'll use BigQuery to build one of these models. And before we do that, we'll get into how we can explore some of that data for the purposes of building our model. So the next video will be a little bit more of a walkthrough of the particular problem in BigQuery and the Austin bike share data. Hopefully this is insightful, and we'll get back into it in the next video. Thank you for watching.